Hi everyone, this is the first video for section 7.3 on multiplying and dividing decimals. So we are going to start with looking at models of multiplication. Just like how we've always done, we look at models and we look at algorithms. So we're going to start by looking at multiplication models. Okay, so the first problem that we're given is to multiply 1 33/100 times 4. So in order to more easily use a model for this, I'm going to rewrite this using the commutative property as 4 times 1.33, where we have the 4 in the front. And so if we do that, we can treat this as, since this is a whole number times a decimal, we can use the repeated addition model. So we want to use repeated addition. And we want to do that with base blocks. Okay, right, because if we have a whole number times anything, we can just treat it like repeated addition. And in order to kind of see what's going on here when we do repeated addition with a decimal, I want to show you that using base blocks. So remember that whenever we represent a decimal number using base blocks, we first have to note which size base block will represent 1. So because we have a 3 here in the hundredths place, that means we're going to use a flat to represent 1. So I think one kind of clever way to know what's going to represent 1 is that normally our unit is a 1, our long is a 10, and our flat is 100 in normal base 10 blocks when we're not dealing with decimals or fractions or anything. So if your smallest place value is a 10th, then the 10 long will represent your unit, or represent 1, I'm sorry. And likewise, if your smallest place value is a hundredth, then the flat 100 will represent 1. So that's kind of a nice trick to have the smallest, whatever your smallest place value is, the corresponding, like for example, if it's hundredth, then the 100 base block will represent 1, is a nice little thing to note. Okay, so we want to do this repeated addition. So what we're going to do is we're going to represent 1.33, which is 1, and then 3 longs, and then 3 units. And we are going to have that 4 times with our repeated addition. So we have 1, 3, 3, 1, 3 longs, 3 units, and then we have 1 more. And then 3 more here. Okay, so we have all of these things, and so now we want to combine them. Okay, well, probably should have written this where it was easier to combine. So I'll rewrite it over here. So now we have 1, 3, 3. And then 1 more. Okay, so now we have 1.33 represented in base blocks 4 different times. So we can start regrouping. So first I'm going to regroup our units. So I'm going to take 10 of them. So I'm going to take these 10, and I'm going to make a long out of that. And then we have 6 longs on this side, 7. And we can regroup these 10 longs to give us another flat. Okay, and we can't regroup the flats at all because we just have 5 of them. So what are we left with? We are left with 5 flats. 1, 2, 3 longs and 2 units. So we're left with 5 flats, 3 longs, and 2 units. And remember that a flat represents 1. So we have that 4 times 1.33 is 5.32. So that is our answer right here with all of our work there to the side. Okay, so that's how we do that using base blocks and repeated addition. You can also, what we're going to show in this next one, use base blocks with an area model. So we're going to use an area model, and we're going to use base blocks with that area model. Okay, so here we have 2.4 and 3.3. So the smallest place value is the tenths here. So that means we're going to use a 10 or a flat to represent 1. So here we're going to have a flat represents 1. Okay, so remember whenever we use an area model, we line things up in this table of sorts. So we're going to have 2.4, so 1. No, that's a little long. 1, 2, and then 4 units. Okay, this is a multiplication. So then we'll have 3.3, so 3 longs and 1 unit, or sorry, 3 units. Okay, so then we just do this multiplication like we normally do. So 2 longs make a flat. Remember that we think about 2 longs make a flat because we think about it as being the length and the width of the new shape that we get. So if we have a length of 10 and a width of 10, we're going to get a square, which is this flat. Similarly, when we do a long times a unit, well, anything times a unit is just itself, right? So we're going to get a long back here and here. Okay, and then for these units, everything right just copies down. So we're going to get a long 3 times and another long 3 times. Remember, units times units gives us units, so we're going to have 12 little units down here. And so my area model is a little bit off, so I'm going to put those last row right here. Okay, so now we would normally regroup this and then write it down. However, remember that in our factors, right, where this is our factor, that in our factors, we have that a long represents 1. And we know that whenever we multiply a long by a long, we get a flat. However, we also know that whenever we multiply 1 times 1, we just get 1. So that means that our flat represents 1 in the product. Because if in our factors we have a long represent 1, that means that a flat times a flat, 1 times 1, I'm sorry, I misspoke. Let me say this again. So in our factors, we have a long represent 1, but we know that a long times a long is a flat and 1 times 1 is 1. So that means that a flat has to represent 1 in the product. So let's start regrouping. So we have 10 units here that can go 2 along. And we have all of these longs that can, I'll make it out here, can go to a flat. And then we have 1, 2, 3, 4, 5, 6, 7, 8, only 9 longs left, so we cannot regroup anymore. And we have 7 flats, and we can't regroup those. So we are left with 7 flats, 1, 2, 3, 9 longs, and 2 units. So that's what we're left with. So that tells us that 2.4 times 3.3 is 7.92. Remember that 9 is our flat, represents 1 in this product. So from this area model, you can kind of reason out why whenever you multiply a tenth and a tenth, you end up with 100th. It's all because we have a long representing 1 in the factors, but then a flat representing 1 in the products, just to preserve that we know that 1 times 1 is 1, and we also know that a long times a long is a flat. So this model can kind of tell us why we end up, when we multiply decimals, we get more decimal places than we started with. You can kind of see that from this area model. But we can also see it if instead we do things using fractions. So we want to multiply 2.6 and 3.2 using fractions. I don't want to do this problem. I just want to do the same problem we just had. It's close enough. So we are going to multiply 2.4 and 3.3 actually. So the same problem that we just did. We're going to do this using fractions. And we already know the multiplication algorithm for fractions, so we can just use it. So 2.4 times 3.3. So we know that we can represent 2.4 because 4 is in the tenths place. We can represent this as 2 and 4 tenths times 3 and 3 tenths, right? And so remember that in order to multiply mixed numbers, I think it's a lot easier to write them as improper fractions. So we know that 2 is 20 tenths. So this is 24 tenths times 33 tenths. And we can, right, if we multiply, we can multiply straight across. You can also rewrite this using the prime factorization, however you want to do it. But if we do 24 and 33 over here is a little scratch work. 3 times 2 is 12, carry the 1, so we get 7. And then 3 times 4 is 2, carry the 1, we get 7 again. So this is how we get 792. So we're going to get 792. And when we in the numerator, and when we multiply the denominator straight across, we get 100. So this is another way that we can see that when we use fractions and we multiply our denominators, that multiplying tenths together will give us hundredths because of the multiplication algorithm for fractions where we multiply straight across. This is another reason why we can see how this works. And then 792 over 100 is just 7.92. Okay, so all of this, the reason why I chose to kind of show you these models first is because is to help inform why when we multiply 2 tenths together, we end up getting 100th. And you can see that from these base block models, but also this fraction algorithm. So next time we will talk about the algorithm in the book for multiplying decimals in a little bit more detail. So that's all for this video.